guys, welcome to the video from section 3.4 where we're going to talk about variation, which may be something you have or have not heard about before. So the first thing I want to do is let's just read through what variation is. So these are the definitions. We're going to start there and then we're going to unpack it. So just bear with me for a second. So direct variation. We say that y varies directly as x means y equals kx, where k is a real number called, the constant of variation. I wrote this and it was just me, and I guess there's every once in a while there's going to be some grammar errors in there. My degree is in math, not in spelling. My apologies. Okay, so we have this thing y equals kx. K is just always the constant of variation. That's the thing that you need to know. So pay attention to the next definitions. Inverse variation. We say that y varies inversely as x means y equals k over x. K is still the constant of variation. And then we have joint variation. Y equals kxz. K is still the constant of variation. Okay, so I realize at first when you look at these definitions, they probably feel like meaningless and we don't really know what they're trying to get at. But this is trying to explain how two things relate to one another and by what operations they are related. So for instance, direct variation. So this is talking about multiplication. Direct means that two things are related by multiplication. This is talking about how things are related by division. And then joint variation means that, I guess you could think of it as a lot of multiplication, right? So let's try to create some intuition with this. The key to variation is actually in understanding these definitions. So I'm going to spend a moment talking to you about this. So I want you to look at where the k's are in all of these. So my k is here, here, and here. If you thought of all of these as a fraction, i.e., so pretend that for a second this is like a fraction over 1, where is k in all three of these equations? K is really always in the numerator, right? So that's very important to understand when you're trying to understand these definitions. And so if you know that, now let's break this down a little bit farther. Notice that for all of these, they say y varies. So if I highlight this, y varies, y varies, y varies. In each case, when we say y varies, what does that mean from a mathematical standpoint? That actually gets us to this y equals, right? So when we say something varies, that means that it equals. Then we just have to break down what do these other words mean. Directly as x. So directly as x means that you're going to multiply k by x. With inverse variation, if I say it varies inversely as x, that means I'm going to divide k by x. And then finally, with joint variation, if I say y varies jointly as x and z, that means I'm going to multiply k by x and z. So this is very important to notice when you start this, because this is really going to unlock the key to how to work with variation problems. So now let's go to the next page. So where variation gets used is with situations like this. Michael's salary varies directly with the number of hours that he works, or if the distance is constant, then the time it takes to travel to a particular distance varies inversely with the speed traveled. So these are situations that we're going to work our way up to. Where we want to start actually is down here with example 1. So the first thing I want to get you used to is working with kind of the language of variation. This is the most important thing. So thinking about what we just talked about in the last page, for example 1, and for all of these, all I want you to do is just write out what the equation is. So I have L varies directly as M. So we talked about with y varies. Now I've changed the letters effectively. So L varies will mean that L equals. Then we know that k is always a part of the problem. So what do I need to do to a? K. I need to multiply it by m. That's what it means to vary directly. Okay, so now let's try this again with b. A varies inversely as b. So a varies, we know, will mean a equals. And now inversely is b. So what does that mean that I'm doing to k? That means that I've got k on the top because k always goes in the numerator, and I'm going to divide it by b because that's what it means to vary inversely. So I want you to try these last three examples. Hit play when you're ready. Okay, so now it says p varies inversely as the square of x. So notice that this says the square of x. So what does that mean? So we've got p varies, so that's p equals. Inversely means I want to divide, but it says I want to divide now by the square of x. So here's x, and here's what the square of it looks like. So I get p equals k over x squared. Next, I've got a varies jointly as b and the square root of c. So again, pay attention to this part here, the square root. Okay, so now a varies. That means that a equals, and now we'd write down k. Now what are we going to do to k? We're going to multiply it by b and the square root of c. And last but not least, we've got m varies directly as n and inversely as l. So this one I know can be a little bit tricky. So you only have one k ever with variation. So we know that m varies means it's going to be m equals. So everything's just going to be done to this one singular k. So that's something I didn't mention before, but that's the way that this works. So directly as n means I multiply k by n. And then inversely as l means I'll divide this whole thing by l. So now you have that k is simultaneously being multiplied by n and divided by l. So there's the idea behind this. Okay, so now let's take a look at some typical problems on the next page. Okay, so on this page, I'm actually going to walk you through the steps that you really need to solve variation of problems. So I'm outlining the steps here. You see how I've got all these pieces. So I want to outline the steps, and then later on you'll just take these steps for granted. You'll know what you need to do. So starting with the first one, y varies directly as x. If y equals 20 when x equals 10, find y when x equals 5. I know that looks like a lot, but we're going to break it down in steps. So to begin, it says determine the general variation equation. So that is talking about this first sentence here. So maybe I'll just kind of highlight that. Determine the general variation equation. That is what this is trying to get at. And so if I just write that out, this is going to be y equals kx. That's what it means for y to vary directly as x. Next it says, using the information that was given, solve for k. Okay, so this is going to line up to this next part of the problem. If y equals 20 when x equals 10, that's telling you how the quantities relate to one another so that you can solve for k. So I'm going to replace the y with a 20. I'll leave the k alone, and then my x will equal 10. So now I just have to solve for this. And to do this, you know that you would just divide each side by 10. So I would get that my k equals 2. In the next step, what you want to do is restate the general variation equation with the new k. So this is now referring to using both this piece here and this piece here. So I just want to fill in that k, but I leave the k, or I leave the y and the x alone. So I get y equals 2x. That's all we need for that one. So you always want to restate the equation so you remember what you're working with. And now this says solve for y. So I'm running out of some colors here. Maybe I'll use the orange, solve for y. So this is saying find y when x equals 5. That's the part that we need to solve. So if I know that x equals 5, I just plug that in, and then I'll ultimately get that y equals 10. So that's really what that's trying to get at and ask for. So the next example on this page, this next example is using the same directions. So I want you to pause the video and take all these directions at your own pace. Then check your work by hitting play when you're ready. Okay, so it says, suppose L varies inversely as M. If L equals 24 when M equals 2, find L when M equals 4. So first things first, we determine the general variation equation. So that's L equals K over M. Because this is talking about this first part in here. Then it says, using the information that was given, solve for K. So now I have to replace these things, right? So I'm going to use this information that was given. This is the stuff that's given up here. So this is 24 equals k over 2. Now in this case, to solve, I need to multiply each side by 2 to get the k by itself. So ultimately I get that k must equal 48. Now I need to restate the general variation equation with the new k. That's referring to this piece and this piece so that I can do this. So this is L equals 48 over m. That's all we need. And now I need to solve for L. So that's this last piece, this part here, find L when m equals 4. So this is L equals 48 over 4, so this equals 12. So those steps are usually not all laid out for you. You have to just know to use them. So you might need to reference this page as we move on to the next page. So let's go to the next page. Okay, so let's do this first example together. So now we're really using all those steps from before, except now you're just not being outlined with them. Suppose x varies inversely as y. If x equals 12 when y equals 3, find x when y equals 9. So now I just do all those steps on my own. So first I have to write out the general variation equation. So I have x varies inversely as y, so that's x equals k over y. Next I have to solve for k by using the information that was given. So it says if x equals 12 when y equals 3, so let's plug that in. 12 equals k over 3. To solve for k, I need to multiply both sides by 3, so I get that my k equals 36. From here, I need to plug this in to my equation. So I get x equals 36 over y. And now finally, I can find x when y equals 9. So now I need to plug in my y. So this is x equals 36 over 9. Okay, so those are all the steps, and you know, make sure you're pausing the video and kind of taking in each one of those steps as you need. Part of the strength of these videos is you can pause whenever you need. So what I want you to do now is I want you to try example B on your own, and then when you think you've got it, hit play when you're ready to see the solution. So this says suppose m varies jointly as n and p. So that means m equals knp. If m equals 40 when n equals 2 and p equals 4. So let's find k. M is 40. I don't know what k is, but I know that n is 2 and I know that p is 4. So now I have to solve for this. So probably it would be in my best interest to multiply 2 by 4. So I get this side actually simplifies to 8k. And now I can solve for this a little more clearly. So I get that k equals 5. So now I can restate this equation to be 5 np, and now it says find m when n equals 5 and p equals 2. So this is m equals 5 times 5 times 2, and if I multiply those all together, I will get that m equals 50. So 5 times 5 is 25, times 2 is 50. Okay, so let's do one more example. Example C, same idea. Pause the video, hit play when you're ready. Okay, so it says A varies directly as B and inversely as C. So we talked about that before, right? To vary directly as B means I multiply K by B, and to vary inversely as C, I divide by C. So now, if A equals 20 when B equals 2 and C equals 5, okay, so let me plug in that information. So my A is 20, my B is 2, and my C is 5. So unpack this in whatever way that you need. For me, I'm going to first just get rid of the 5 so I don't have a fraction. So now I've got 100 equals 2 times k, and now I can divide both sides by 2, so I get k equals 50. So now I can restate this equation as A equals 50b over c. So now let's finish this. It says find A when B equals 8 and C equals 2. So I will replace my B with 8, and I will replace my C with 2. So now I can just multiply these together. So 50 times 8, that's going to be 400, and then I need to divide that by 2. So let's see, it looks like I'm maybe running out of room on the camera, so I'll write this over here. A will equal 200. And so there's the solution to that. So this is the general idea, and in the next video, we'll talk about just some applications of how this works. So I'll see you guys in the next video. Thanks for watching.